Hey, what's up, pre-calculus? Today, let's take a look at some beginning information about horizontal and oblique asymptotes of rational functions. All right, I have here a couple sample functions graphed for us. We don't need to worry about their equations right now, but let's just think of a horizontal asymptote and, just kind of realize it is a horizontal line that the ends of a function approach but never touch. So we'll fill this in a moment, but let's take a look at the first graph here. If you look at the very left end and the right end of the graph, they do seem to be getting closer to, but never touching this horizontal line here, y equals 2. And that will be the equation of our horizontal asymptote. It is the horizontal line the graph gets closer to without touching at the ends. When we look at this graph in the middle, you can appreciate, I hope, that the right end of the graph and the left end of the graph are getting closer to the x-axis, which is the horizontal line y equals 0. You might be a little perturbed how in the middle of the graph, we do show the graph crossing through the horizontal asymptote. I do want to let you know that is okay. That will happen when we get to some more advanced graphing. And since this is not anywhere close to the end of the graph, like the left end, the right end, that is okay. So the equation of this line here is y equals 0. There's our horizontal asymptote. Shake your asymptote. All right, let's look at the third one here. We seem to have something a little bit different happening here on the left as we see happening on the right, and that's okay. So let's just kind of note for the horizontal asymptote, there are going to be, well, two of them, one for the left side, one for the right side. So over on the left side, our function's graph is getting closer to the horizontal line y equals positive 1. And over on the right side of the graph, the points seem to be getting closer to, but never touching, the horizontal line y equals negative 1. Okay, so that will happen with some more advanced functions, and just list them both. So what we're really looking at here are the limits at infinity as x approaches negative infinity or positive infinity. That's really what we mean by the ends there. And if each of those limits come out to some random constant c, that means the line y equals that number c is the equation of the horizontal asymptote. So when you have the graph already made, it's very easy to identify where the asymptotes are just by looking. However, we do wish to be able to come up with this information without having to go through the graphing process. So our next line of defense here would be to consider maybe a table of values to help us determine mathematically what these horizontal asymptotes could be. So I have here a little table of values. If you notice, though, we're not essentially barreling towards an undefined value, which would be x equals 1, but we're actually working our way from the middle of the table out. So how about this? Could you all grab a graphing calculator, type this function in, and fill in that table of values, and I will pause the video and catch up with you after that is done. All right, welcome back. Let's take a look at how that table played out. So I've recorded all of these values in this table and how we can set forth and try to analyze what's going on. So as I mentioned before, walking from the center out, these x values are approaching negative infinity, and the y values do seem to be honing in on the value of 3. That is seemingly what's happening as we push out from the middle of the table to the right. These x values, 100, 1,000, 10,000, they're just getting bigger and bigger and bigger. And the y values seem to be closing in on a value of 3, getting pretty dang close to it. So as we think of these limits, limit towards negative infinity, f of x equals 3, and the limit as f of x approaches positive infinity is also 3. And we would then conclude, okay, the horizontal asymptote here must be y equals 3. So that is a way to do it without analyzing a table, without graphing. But I would say even this is maybe not something we'd like to do every single time we need an asymptote. So I would like to speed this up a bit and share a little limit fact with you. So let's think of some generic function with some random number, just a constant like 2 or 5 or 1, up in the numerator, and x to a positive exponent, any positive exponent down there in the denominator. Well, a cool limit fact to know is that when we divide by these powers of x, as x approaches negative infinity, that limit equals 0, and as x approaches positive infinity, that limit also equals 0. So I'd like to kind of demonstrate that to you with something we already know about, the function y equals 1 over x. We have graphed that function already this year, and just looking visually at the graph, we do get the sense that at the left end and the right end, the graph is getting closer and closer and closer to the x-axis. We know that from sketching it in the past. Algebraically, mathematically rather, we would also draw that same conclusion. And if I go into the table and try out some values of x that are pretty big, like negative, oh well, look at those same numbers from before. I'm just going to repeat them. And we see as we type large and positive and negative numbers, same thing happens. As I just kind of talked about, these y values are getting pretty dang tiny. Think about what that capital E means, -1 times 10 to the -4th. That is so tiny of a number. It is very close to 0. And we should then conclude, okay, yes, officially, mathematically, the y values get closer to 0 as x gets rather big and negative or big and positive. And the same would happen for analyzing 5 over x cubed as we use larger values of x. Dividing 5 by that enormity works out pretty dang close to 0. So I'm just going to kind of hit you with a very obvious fact here. When you divide a very small, reasonable number like 1 and 5 by something very big, the result of that division gets closer to 0. All right. Well, we can analyze something with a graph if it's already drawn. We can analyze something with a table if we feel like doing that. But what I'd like to just introduce you to in the last couple little pieces of this video is how to use this fact to kind of quicken up the pace a little bit. So we're going to look at this same function here at the top of the next page, and we are going to just rewrite this function in a pretty telling way in order to find that same information. So let's do a little rewrite here. And I do want to rewrite this in a way it's still mathematically valid. It still means the same thing as the original function, but it is just displaying something a little different about itself. So I'm going to look at this function here. I'm going to notice the highest power I see is x to the first. So check this out, everybody. I'm going to divide each term from that function by x, the highest power. That is valid. I am not shaking up the universe. I'm not changing the function's inner self. I'm just kind of changing its outfit. So let's think about what that does. The first little tiny fraction just reduces to 3. Second little tiny fraction does not reduce. It stays 2 over x. Oh, down here in the big denominator, x divided by x is going to reduce to 1, and then we'd have minus 1 over x. So this, first of all, looks a little awful. Fractions inside of fractions. Ugh. But the way it is written is pretty telling, because think now of this tiny little fraction and this tiny little fraction. We just examined things like that, and we know as x gets very, very, very big, the tiny fraction overall gets very, 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 very small, very close to 0. And you get very close to mathematically simply dividing 3 by 1, which gets very, very, very close to 3. Never equals 3, just gets very, very close. If we were to write that with limit notation, it looks something like this. The limit as x approaches negative infinity of f of x equals positive 3, and the limit as x approaches positive infinity of f of x equals positive 3. And the conclusion that we then should draw from that is there is a horizontal asymptote, and its equation is y equals 3. And we will pick up with that discussion at another point, but I just wanted you to get introduced to the idea of rewriting. That's all for now, everybody. Hope you enjoyed this lesson. Shake your asymptotes.